Hi everyone, I welcome you back in this tutorial series of end-to-end machine learning model development. We had seen data handling and we wrote the functions for loading the data, saving our model and then loading back our model. Now we are diving into world of data pre-processing. We'll break down the Python script step by step and explain each custom processing pre-processing class. That means we are going to create the classes or we will follow the object-oriented programming in which we create the class for data pre-processing. These classes will handle the common data pre-processing tasks such as imputation whenever the values are missing, label encoding for the categorical data, and feature engineering wherever it is required. I have simplified this script a bit to make it beginner friendly while retaining its functionalities. Okay, so let's get started with this thing. So just below data handling, I created a file called data pre-processing. In this data pre-processing, the very first thing that we will do, we'll import the necessary libraries and the necessary modules. For example, we need this config file. So for config file, we'll import over here from loan app dot config import config. Okay, and then we will import numpy as for calculation of some of the statistical values such as mean, median, we require numpy. So after importing it, let's try to execute and check if my modules are getting imported properly or not. Okay, so it is showing the same error, no module name, loan app. So what do we need to do? How can we fix it? We can fix it by adding the path into the Python or directory from where it can easily access the modules, right? So I'll just use it over here. All right. Now I guess things should work. Only thing we required what we need to import sys. All right. Now I hope things should work. Let's see. Okay. So it is saying name OS is not defined. So I need to import OS as well. Okay. So things are working now. Now we'll start writing the logic. So what do we do? First of all, we'll start with the mean imputer class. So the class fills the missing value in the numerical feature with their mean. Here we will in the class we will have two methods. The fit method will calculate the mean and transform method will fill the missing values. What I mean, let's see, I'll create a class over here, class mean imputer. All right. Now in this class, the very first method will be what the constructor in which I'll define as a init. All right. And what I said, we will use the fit method to calculate the mean. So fit, all right. And next we will use the transform method to fill the missing value, to fill the gaps. So this will be the structure of your class. Now how it will work? It will work in a similar way if you have ever used any pre-processing module in your Python, or you can say Python based machine learning model development. Let me show you where you had used it. So in the Python based development, if you have ever used pre-processing thing like this, you see what you did. You first imported the module minmax scaler like this, and thereafter you fit the data over here, and once you fit, it calculates the matrices required for the scaling, and then through transform we are using it. So these are the inbuilt methods or inbuilt classes that we had used, but now we are going to create our own class which will do the same kind of transformation. So let's see how can we do it. In this thing, in the init, we will define over here the variables. Okay, so by default variables will be defined as none. Okay, and then I'll define the attribute over here, self dot variable is equals to what? Variables. All right, so this is it. Now we will do what? We'll based on using these variable, we have to calculate the mean, right? So now we'll just use over here the parameter x and y. X will be the feature and y we will define over here as a none. By default, default value of y will be none, because when we use it, we'll fit xtrain and ytrain. So I need to just make the changes in the xtrain, ytrain will remain as it is. So that's why the default value I use none, and when we use ytrain will just replace the y. Now we'll do what? We'll calculate over here the mean value. Mean value of what? Mean value of the variable that we had already passed. How can we calculate the mean value? So in the fit function, we have to write a logic which can calculate the mean. So for that purpose, we'll run a loop over here for variable in variables, or if for VAR in variable, that means if you have multiple variables, each column will be accessed over here. Now, or you can say here I should use self dot variables. Okay. And then I can call over here. How can I calculate the mean? So for calculating the mean, x of VAR dot mean. All right. Now what we do, we'll store these mean into the dictionary. So how can we store this into dictionary? Let's say I'll define a dictionary over here, mean dictionary. Because I have to calculate the mean for multiple data columns, right? So for each data columns, we'll just define self dot mean underscore dictionary VAR is equals to, right? So this is how for each particular variable, the mean will be calculated and stored in the dictionary. And at the end, I'll write over here return self. That means whatever the value it calculated, just it will return it. Now in the transform section, I will make use of it to update the column. Wherever the missing values are there, they will get filled up with the mean value. So for that, for VAR, in variables, that means access each variable one by one that we are targeting. Like suppose you're targeting all the numerical columns, so it will just access or loop through the each data column. And then we do what? XVAR is equals to XVAR dot fill NA. Okay, how can I fill it? To fill these things, I will take the value from this dictionary, right? So we will just take this thing from here, the dictionary. Okay, and then VAR. Okay, and at the end, we'll just return what? X. Okay, so when I trigger this function, what we do? First of all, we'll fit the data. And once we fit the data, it will calculate the mean value for the numerical columns. And when we use transform, it will do what? It will just transform the value, or you can say fill the null values with the mean value. Similar kind of approach we can use for the categorical things, like this is for the numerical. For the numerical, we used mean. For the categorical, we'll use what mode? Okay. So for that, what I do, I'll just try to take this thing that is your this particular class. Where is it? Okay. So I'll just try to copy this thing and I'll make the required changes because similar logic will be there. So here I can use mode imputer. All right, just like mean imputer, we will have the mode imputer. Next, what we will do, we'll just use over here a tab. Now we have these things variables defined in the fit section. Here we'll calculate mode, right? Index 0. And then it can be a mode dictionary, isn't it? So cell.mode dictionary, cell.mode dictionary, and this can be done, I guess everything is correct. Next, what we need to do, we can just go to the transform. In the transform section, here I will just use cell.mode dictionary. Okay, and then VAR. So whatever the value is stored, that will get filled up and fill up the missing values with the mode value. Now this is done. Next, what we need to do, we need to define a class for dropping out the columns that we don't need, right? So for dropping out the columns, we'll create over here drop columns. All right. So here what we do, we'll create a class drop columns. Okay, and then we will have the same function. First it is init. Okay, next we will have what? Def fit, and next we will have what? Transform. All right. So init will do what? Init will just init will be used for defining your variables, that the columns that you want to draw. So for that, let's see, here we will define self comma variables to drop. That will be equals to what? By default, it is none. And then we can just call it, right? So it's like self dot variables to drop is equals to variables to drop. That's it. And then we have a fit. So in the fit, I'll define over here x comma y. Y will be by default none. So here actually we don't have to do anything, because for dropping we don't have to calculate any kind of value, right? So I can just use over the return self, that's it. And in the transform I'll drop it. So x will be equals to what? X dot drop. Okay, what I need to drop? Columns is equals to self dot variables to drop. All right. And then I'll return x. All right, that's it. Right. Next, we have to do what? We have to do the domain specific processing. In this section, the domain specific processing, we are just adding the what was that? The applicant income with the co-applicant income. So that is what we have to do over here. So let's say we'll define over here domain specific processing. Okay. So for that, let's say class domain processing. Okay. Here we'll define it. Next thing that we have to do what? We will work on a custom label encoder. Obviously, the categorical things needs to be encoded. Okay, so for that class custom label encoder. All right. Next thing we will do what? We have to perform over a log transformation, right? So here log transformation. Okay. So here class log transformation. All right. So these three functions, these three class that we have to create next. So what we did, we had created few class for data pre-processing. For example, mean imputer responsible to impute mean value wherever the missing value exists. Mode imputer to impute, or you can say the mode value in the categorical column. There is a certain change we need to do. Say here, this class becomes the part of mean imputer. So let's fix it, okay, like this, so that things can work better. Here I'll just fix it. All right, now it seems to be good. So now we can do what? We can go for the domain based processing, in which I told you here we need to sum up the applicant income with the co-applicant income. So for that we'll write the logic. First we required initializer, so I'll just finish up writing the initializer code. As of now, I'll just define the structure and later on I'll finish up the code. Next, we required fit function. Next, we required the transform function, right? So now it is done. Now let's define the variables, or you can say the variables like in which column we have to make the changes. So that we will define in the constructor. So here I'll define two columns, or you can say two variables. First, the column that I want to modify. So variables to modify. That will be equals to what? None. Next, we have to define over here variables to add. That will be equals to what? Again, none. Now, here I will define both the variables. Self dot variables to modify is equals to variables to modify. Self dot variables to add will be equals to what? Variables to add. Now our variables are defined. Now again here when we will sum up the two columns, there is nothing to do in the fit. So I can just use over here return self. Okay, because here we don't have to do anything. Only I'll define the x and y is equals to none. All right, that's it. All right, now let's go for the transform section. So in transform section, we need to kind of write a logic which can sum up the two different columns values, right? So for that, what we do, for feature in variables to modify, like suppose if I'm working on multiple features, so each features it will picked up. Now x feature, okay, will be equals to what? The x, that particular feature, plus the variable that you want to add over here. So self dot variables to add. Okay. So in case if you're working on the multiple features, so it will just add those things together, and x should be a parameter over here, and then at the end I'll return x. So this thing will transform your data. I hope this is fine over here. Also, I should use x. Now it's fine, I guess it's good. And then, okay. So now we can go for the next function, which is custom level encoder. So in custom level encoder also, obviously I required this thing, that is your init. So let's define over here init thing. Okay. All right. So this is my init. Next, I have to define over here the fit. Next, I have to define over here the transform. All right. So now what kind of logic we require in custom level encoder? First of all, in custom level encoder, which columns to be encoded, that I'll define in the constructor. So let's say variables is equals to none. Next, what we need to do, we need to define over here all the variables in a attribute. So self dot variables is equals to the variables that I am passing while creating the object for this class. Now in the fit, we need to do what? I will just define x and y over here. Okay. And then I need to write the logic. So let's try to think of the logic. What we need to do, we need to find out all the unique values in a particular column. And based on the unique values, we need to do what? We need to, for each unique value, we need to assign a particular numerical value, right? So for that, let's say I'll use over here for val in self dot variables. So in that way, I can just access each column one by one. Now for each particular variable, I can just find out the unique value. So for that, x val dot unique. Okay. So this will give me all the unique value in any particular column. First column, second column, third column, fourth column, like that. Once I have these uniques value, what we can do, we can just store this thing in a particular variable, let's say t. Okay. Now what I do, I'll just define over here a dictionary self dot label dot or self dot label dictionary. That means suppose I'm working on label encoding. So obviously the label encoding will be done for all the categorical columns. That means the label encoding will be done for more than one column. All right. So what we do, we'll just create a dictionary over here, and this dictionary will contain the name of that particular value. Like suppose there is a category rural, urban and semi-urban. So here label of dictionary, this will have what? The name of the column. Okay. So column name, it can be like whatever the location. Okay. So location will be our key, and for that key, again I'll define over here a dictionary. Okay. And within that dictionary, the information will be stored like, okay, rural colon 0, right? And thereafter urban column 1 and semi-urban column 2, like that. So for that, what we can do here, we will have over here, okay. So here we can write for category in, okay, here, let's say I'll define over here categories, different categories that we get. So for category in categories, okay, each category it will access. And then if I use enumerate over here, in that case, I'll get the index as well for each category. So that index I'll store it over here, I comma this one. Now what you can do, if I'll define CAT for I comma CAT, that means I'm just accessing each category name one by one. Now what to do with that particular category name one by one? I'll do what? Let's say here if I'll access I, that means I am accessing index value for each category, like 0, 1, 2, like that. And now this index value I'll store against the category name. So that's kind of a key, like rural 0, urban 1, and semi-urban 2. That's why it can just store the value. And then I'll do what? Return self. So this will define the dictionary in which each category will be assigned with a unique numerical value. Then in the transform section, we'll write the logic which will do the mapping. So for mapping, what we do for val in self dot variables, okay, here x val will be equals to x val dot map, okay. And what I have to map? I have to map the values that I defined over here. All right. So according to the values defined in the dictionary, the encoding will be done. But here I need to feed x as a parameter. And here I'll do what? Return x. Now this function will do what? Or this class will do the custom label encoding for each variable or for each unique value in a categorical column. Next, for the log transformation, it is going to be very simple. We just define over here init. Next, I define over here fit. Next, I define over here transform. All right. So now let's say in the init section, I'll just define variables is equals to none. Okay. So now I'll define self dot variables. That means for which column I want to do the log transformation. That's what I'll define it over here. All right. Now for the log transformation, again in the fit section, we don't need to do anything. So just define x comma y is equals to none and just return self. No calculation, nothing. Directly I can define over here that, okay, for each columns for VAL in variables, that means for each data columns that we have, okay, I want to do the, or you can say self dot variables. I want to do the log transformation. So x VAL is equals to np dot log of x VAL. And then at the end return x. And here the things are done. So it created all the classes over here, which will first take your data, do the calculations with the help of fit, whatever calculations required, and with the help of transformation, it will transform your data. Next, we have to use these things into our model pipeline. So the next video that we are going to discuss, or we are going to, in the next video, we are going to discuss about it. How can we use it in the model pipeline? And then at the end, we'll train the model and save the model. So till then, keep learning and stay safe. Thank you, everyone.